In this fourth part of the setting up simple network study, we're going to work with the same data set that we had before, which is a road network, and we've got kids and we've got schools. We've got 18 kids and we've got 3 schools. In fact, the majority of the time is going to be used for the schools. And what we are thinking of this time is setting up a role and understanding what areas should be sort of serviced by each school. So rather than looking from the distance from each student to each school, we want to provide a map indicating what areas are the closest to the schools in terms of transportation. We can do that in many kinds of ways. We can do it by an area basis, or we can do it by a network basis showing the roads themselves. Or we can combine them both. But the way of doing it is usually through the network analyst's new service area. And by starting it, as we've seen in the previous models, or when we've been using the sort of simple network, we get a few objects. We've got facilities, we've got the point barriers, lines and polygons and whatnot. We are not using polygons here, and we are not going to use the errors. And please note that this sort of the right hand things, the ones of the table of contents, are only the results. What the things that you want to enter in the models are here in the network analyst's sort of table or whatever, where you've got the facilities that in this case should be understood as schools. So if I drag and drop schools, we've got this message that we always get with the definition of how to assign network to objects. We have 3 facilities, and those are clearly marked, looking like eyes with a blue pupils in them. And these facilities are the schools, and we want to find out how the network surrounding them looks. And doing that means that we can use the service area properties, and in difference from many other of the alternatives, this time we get quite a lot of alternatives to do. The really only setting I want to do is not in this tab, but it's interesting to note. We could choose overlapping multiple facilities options where we in fact generate polygons, and the polygons will show the area that are within a specific distance. And allowing it to be overlapping means that we've got multiple areas depending on what kind of object and origin we make use of. We got analysis setting, which means that we can also choose to design the cutting points of these areas. So let's assume that we have one color for the area within 1,000 meters. We have another one with 2,000 meters. Let's take a third one with 5,000 meters. And finally something with 10,000 meters. I don't even know if that's going to be a value that is going to be shown, but nevertheless. We can also look at the other ones, source, layers, general. When it comes to line generation, it is a possibility for us to generate lines. This will actually generate a lot of lines because each road will then have a separate line. But the beauty of doing this is that you could export the lines having the value of the exact distance at that road segment from the object, in this case the school, that provides the service. You could use it in metrics, but I'm not going to do this time because it slows down the analysis and it doesn't do really much more than what I just said. And since we are just using metrics and not costs and time, the end results is just communicating the meters from the origin or to the destination. So literally that. You can have the accumulation of length and network locations and so many different kinds of things, but I'm going to be ready and done with the settings I've done, and I'm going to press OK. As in previous cases, it doesn't really happen anything, it's just sort of the rules for the model, and when we press the solve, that's when the action happens. This time it's going to take a little bit longer time, but not very much, as you could see. But what is being produced is instead an area, and those output areas here are the polygons showing dark blue for 1,000 meters, then 2,000, 5,000 and eventually 10,000 meters. And if we zoom in into these areas, we can kind of clearly see that they get it right. We've got areas that are closest to the school, and obviously when we start moving away from schools we get another color. Though I do wonder if the coloration in this case is because we got overlapping one and this is the one being on the top of each other. That's kind of likely it is. We should probably redo it with another setting. So allow me again to redo this analysis. I'm going to take it away. As you can see, we got very interesting light colors very close to school and very other colors here. And this is the third school, and I'm quite sure that the coloration is from the top layer just showing this. So if you allow me, if I take away all the polygons and I'm going to redo the analysis. Let me see, the settings for the polygon generation would be instead that we have this one, allocate polygons to the closest facility. Then we will split the values so they're not overlapping, and I press OK. And this time I click solve, and we get values that are much more reasonable. Because if I zoom in, we could simply see that the darker colors, in this case representing shorter distances, are more common very close to school. And as the network develops, we could see not round or square but rather sort of organic patterns emerging on the various kinds of cutting points. If we had a system where we, for instance, had sort of the right to school transport at various kinds of distances, these polygons would be very feasible and usable to actually set a value for the distance and the rights to free transport or whatever it might be. So this, my friends, would be the service area, a very short version of the service area and how it could be used in analysis.